This definition is from the Scrum Guide, the official document created and regularly updated by Scrum's co-creators Jeff Sutherland and Ken Schwaber. In this video, we will explain that definition and describe the underlying theory of Scrum. Scrum is described as a process framework rather than a complete process for building products. One important distinction is that Scrum is intentionally incomplete. It does not specify all of the steps required to build a product. Instead, it describes the framework within which a variety of processes and techniques can be deployed. The Scrum framework consists of Scrum teams and their associated roles, events, and artifacts. Each of these core components has a few simple rules, and there are simple rules describing the relationship and interaction between the components. Anything not described by those components and rules is not part of the framework. The Scrum team decides which processes and techniques to use within the framework. If the team or the organization were to decide to remove or alter any of the components or their rules, they are no longer using Scrum. Scrum exists only in its entirety, and each of the core components and their associated rules serves a specific purpose. The second part of the definition describes something called a complex adaptive problem. To understand that, let's look at a spectrum. On one end of the spectrum, we will place problems that are simple, predictable, and static, or unchanging. On the other end, we'll place problems that are complex, unpredictable, and adaptive, or always changing. Most professionals are familiar with how to address problems at the left end of this spectrum. Since these are predictable problems, we are able to create a detailed plan. The plan might have many steps and dependencies, but if the system is predictable, the plan will progress without any surprises or the need to change things along the way. This approach is known as defined process control, which means that we define a specific process for every step along the way. This works well when things are predictable. When things are more complex and unpredictable, this approach is not very effective. One of the most frequently cited books on this topic is called Process Dynamics, Modeling, and Control by Babatunde Ogunaki and W. Harmon Ray. In this book, the authors explain, it is typical to adopt the defined approach when the underlying mechanisms by which a process operates are reasonably well understood. When the process is too complicated for the defined approach, the empirical approach is the appropriate choice. Ogunaki and Ray are telling us that the defined approach doesn't work when things are complex and adaptive, and that we should instead use something called empirical process control. So let's explore what that means. An empirical approach is one that is based on observations and evidence. Empiricism is the central idea behind the scientific method, that we can find out what is true through experiments with concrete, observable results. In order to make good observations, an empirical process has three pillars: transparency, inspection, and adaptation. Scrum is based on empirical process control, and so significant aspects of Scrum are designed to provide transparency, inspection, and adaptation. To create transparency, Scrum's events and artifacts are visible to all of those responsible for their outcomes. Organizations using Scrum frequently inspect Scrum artifacts and progress towards a sprint goal to detect undesirable variances. They balance the frequency of inspection so it doesn't get in the way of the work, but still provides sufficient opportunities to course correct. If, during inspections, anything is determined to be outside of the goals of the effort, the process, plans, or product are adapted. The adaptation is made as soon as possible to optimize for a better outcome. To summarize, Scrum is a lightweight framework made up of a few roles, events, artifacts, and their rules that is simple to understand. However, since it relies on empirical process control to address complex adaptive problems, it is difficult to master.